First, I've got to lay out the design on this program I'm using. So there's the design. There's about 75 holes that need to be drilled, and then the board needs to be cut out, and then I'm going to chemically etch the traces. And I'll show the whole process start to finish. So I took a piece of it's called copper clad. It's just fiberglass with a layer of copper, and I've got it mounted to my CNC machine. Get that off of there. It's all ready to go. And first thing I'm going to do is I'm going to drill the 75 holes. Then I'm going to switch to the cutout bit, and I'm going to cut out the outline. So let's go ahead and get started. And I guess I need two hands to do that. So let me get it going, and I'll take a little video of it drilling the holes. Alright, all the holes are drilled, as you should be able to see, and now I'm going to cut out the outline. So let's go ahead and get started. Alright, all the CNC work is done. Now I just gotta pull it off of there and work on the chemical etching. Looks like my outline cutting bit's getting a little dull because it's a little rough there. I don't know if you can see it in the camera, but oh well, it won't hurt nothing. But yeah, next is the chemical etching, so I'll pull this out and get it ready. Alright, here's the circuit board all prepared, and this is called photoresist film, and it's some goo sandwiched in between two thin layers of plastic. So what I'm going to do is I'm going to peel off one layer and stick it to the board, and then once that's stuck to the board, I need to do it yet, but here's some old ones to show you. I'm going to print out a negative of the circuit traces, and that's going to go over top of the photoresist film, And then I'm going to put it under a UV light. And this will block the UV light for everywhere except for where I want the traces to be. And so it cures what actually gets hit with UV light, and the rest I can wash off. So then there will be the traces will be where I want the traces to be, will be covered by this cured polymer, and then I can put it in the chemical etching acid, and it will eat away the copper that is not covered. So I'm gonna need 2 hands to do that. So I'm gonna stick this to the circuit board and print out the negative, and then I'll be back. Alright, I use the laser printer to print the negative onto the transparency, and then I tried to line it up as perfect as I could and taped it to the board. So now I'm going to stick this under here to help hold the transparency flat to the copper. And I'm going to put these on here for weight and for a stand. And this is my UV light. And in 3.5 minutes, I'll take it out of here and it will be cured and ready for me to wash away what didn't cure and then chemically etch it. Alright, now that it is been hit with the UV light, get the transparencies off. And you can see it's purple where the UV light actually touched. So what I'm going to do is I'm going to peel this protective plastic off, and then I'm going to mix a little bit of sodium carbonate and water and use a sponge, and I'm going to carefully remove the goo that isn't purple down to the copper. So it'll just be the copper surface plus whatever is cured purple will still be there, and then we'll etch it with acid. Alright, I was able to wash off all of the goo except what is cured. So this is straight copper plus the cured purple. Now this is a mixture, 2 parts hydrogen peroxide, 1 part muriatic acid. And you always put the peroxide in first. So I already poured it in, mixed it. So we're going to put this in, and it will etch away all of the copper except for what's covered in the purple. And it's only going to take about 3 minutes, so I'm going to videotape the whole thing because it's pretty neat, or at least most of it. You're going to see the liquid turn green, which is the dissolved copper, and you're going to see it eat away at the edges first. Now this piece of copper board is, I think it's white. I think it's white fiberglass. hopefully I wipe the stuff off good enough. This is the second time I've used this method with the UV reactive stuff. I usually just use a laser printer to print onto a piece of magazine paper, and then I use a clothes iron to like do a heat transfer of the printer toner, which does the same purpose as the purple cured photo react. Starting to see the edges go. I'll pull it up out of there so we can see how it's starting here in a second. Now this will etch copper, and it will also etch aluminum. I'm not sure what else it'll etch. You can see what's still there and what's been etched off so far. So I'm going to keep going. Now once it's done etching, then I got to pull it out, and I can use some acetone and Scotch-Brite to get the purple off of the remaining copper traces. The purple goo or photoreact, I'm not sure what it is. It's some kind of polymer. Now in all reality, this is pretty much the same same thing as developing, like developing photographs and stuff. It's the same type of process. And alright, it's almost done, so I'm going to stop the video. I'm going to take it out. I'm going to use acetone and Scotch-Brite to get the purple off of the remaining traces, and then I'll be back. Alright, there it is. All cleaned up. Everything comes out fine. Looks good. The holes aren't perfectly aligned, but I think I was having problems getting that the negative thing to line up with the holes. I think my little CNC machine's not too accurate, but yeah, that's done and ready. It's only a one-sided board. There's nothing on the other side. So what happens is, next I'm going to add all the components and get it going. I've got most of the programming written, and I'm going to use a microcontroller like this, and that's what all these holes in the center are for this microcontroller. And then but it goes on the opposite side. And then I'm going to use one of these touch screens that I like to use. It's just a simple touchscreen module, and that's going to go like that, but on the other side. So this is going to be, as you can see, like that, and this is going to be tucked up under the screen, which means I've got to cut off these little things to make it these yellow pins here, to make it short enough to fit up underneath there. And then I'm going to show it working and stuff. And what this is going to do, well, I got such a mess going on over here, but this is a toaster oven, and it's going to have a temperature probe that's made for high temperatures, and it's going to control a relay, and it's going to precisely control the temperature of the toaster oven, which is for a soldering oven. Basically, you put solder paste on a circuit board, and then you stick in and put all the components on, and then you stick it in the oven and just heat it up, and it all just solders right. You ain't got to sit there by hand and solder each component. That's for doing more complex and very tiny component type of circuit boards. But all right, I'll be back when I get it all soldered together, and I'll already have it programmed just to show it a little bit and stuff like that. All right. Well, here it is, all soldered up. I've got two MOSFETs. One MOSFET runs the beeper. I got a little beeper, and then one MOSFET is an output to the relay that this system is going to run. So yeah, it's all soldered together. So we'll look at the other side, but this is the circuit board we just made. It's just got the microcontroller. This is a little piezo beeper. Two power wires in. This right here is a high temperature thermistor temperature sensor, and we'll be measuring the temperature. And this wire is the output for the heat for the toaster oven. So let's just fire it up. This is a touchscreen, just regular cheapo touchscreen. Plug that into there, and then I got this little I got a power supply for the 5 volts that I've already got hooked up to the wires, but it'll be powered from something different when it's actually put in. Now I've got the code good and started for this, but I've still got a lot of bugs to work out in the code. Oh, there it goes. Alright, so yeah, this is some code I just got started to set up for it. Just let's see. So yeah, none of this is going to work right. This is the temperature reading from this temperature sensor. If you watch it, it actually goes down when I put it on my fingers. So I gotta go in the code and it's reading it backwards. So I gotta fix that in the code. And my countdown timer, I did something wrong. I go back through the code and see what I did wrong there. But yeah, this is it's almost finished, and but you get to see how it all comes together, making the circuit board from scratch. I won't get into the programming code because that's a whole nother thing. But so if I unplug it, I can take this off. Oh, and another thing I didn't show you I got messed with is this beeper was way too quiet. So I just have to change this resistor to a lower value to make it louder. But yeah, it's all soldered in. I put some pin headers so that's removable. And that's how I do it. And now that will control a relay that will control some heater coils and a toaster oven. And it's for a project, but I just really wanted to show making the board and how the start to finish goes on that. I won't really get into what it does and what it's for and all that. So, alright, that's it. Later.